Course 3, Lesson 78, we are looking at the products of square roots. So being able to take these radicals and multiply them together. Now we have a product property of square roots where it says if we have the square root of a times b, that can actually be simplified to root a times root b. This allows us that sometimes if I have the square root of a being a perfect square, I can simplify that. Or if b is a perfect square, I can simplify that. Or maybe we have something like this. We have root 3 times root 12. We can actually multiply these together to say, well, that is the square root of 36, which of course the square root of 36 is just 6. So sometimes we can work back and forth with these in order to simplify our radicals. And we're going to do a bunch of examples here, and then also show how if we have different squares that have radical lengths, we can find the area in a more simplified form. All right, if I have root 42 times root 24, lots of ways to do this. We could split this and use things that we've done in the past, like taking the square root of each of these, or I can multiply them together. And if I do that, I'm going to be doing 42 times 24 gives me 8 and 16, 4 and 8. So 8, 10, and all right, we have 1008. Now 1008 for me is not a perfect square that I recognize or one that I can use super easily. So what I'm actually going to do is work with my 42 and 24 to break them down into simpler forms. So for example, 42 I could split into 6 and 7, which means I can split that 6 into 2 and 3 times 7. And I can also take that 24 and split that into 4 and 6, which means that 4 is a 2 times 2, and the 6 is a 2 times 3. Meaning that in here I'm going to reorganize. We have we have 4 2's, we have 2 3's, and a 7. Which means I have a pair of 2's that I can pop, and it's going to be on the outside. I have another pair of 2's, and a pair of 3's, and we have a root 7 left inside, which means I can multiply what's outside 2, 2, and 3 to get 12 root 7. And that is our simplest form of root 42 times root. All right, how about root 2? Well, we can actually simplify this by saying that's square root. Also seen that square root of 28 is made up of 4 times 7, which means I can take the square root of 4 and simplify that. Square root of 3 times square root of 5 times root 5 means that we have 3 root 25. Well, the square root of 25 is just 5, so we have 3 times 5, which is 15. All right, continuing on for some of these other stars. 3 times the square root of 6 times root 15. We can split this up and say, all right, square root of 6 factors into 2 times 3, and root 15 factors into 3 times 5. So we have a pair of 3's to pull out, which means I have 3 times 3 on the outside and 2 times 5 on the inside. And we can simplify each of these to 9 and root 10. All right, next star. Root 15 times root 3. Now we could say this is the square root of 45, which means I have root 9 times root 5, and the square root of 9 is 3 times root 5. There are many, many different ways to simplify these. And last one on the page, 5 root 3 times 2 root 3. Now when we see things like this, we need to actually multiply the outsides, so we get 10, and we multiply the radicals, which means we get root 9, which really is just 10 times 3, or 30. So we need to be able to multiply these radicals together and simplify as much as possible. Now, another way that this can be in use is thinking about geometry, looking at the perimeters, areas of squares, and seeing how this affects it. So since the area of c squared is 2, okay, we can see how there's 4 half triangles in there. So the length of the diagonal is root 2. Remember, you can do the Pythagorean theorem here to see that. Or you can remember that, well, if we're cutting this square in half, this is a 45, 45, 90 triangle, which means that we have 1 by root 2, because that's our pattern that we found a few lessons ago. Now, if we were to extend this, and instead we have not just one square that we're looking at the diagonal for, but maybe we're crossing 2, all right, so that we have this 2 by 2 square, well, we would say the first one is root 2 and the second one is root 2, so we would have 2 root 2. If you did it by the Pythagorean theorem, we would say that's root 8, which simplifies to 2 root 2. And similarly with 3 by 3, okay, still that 45, 45, 90 triangle, we would say it's 3 root 2, which is the same as root 18. So just showing you that we can extend this to many other things. For example, if we have this rectangle, we need to find the length and the width so that we can find the area. So we do that by taking, all right, we have a 3 by 3 here, 3 by 3. Now we could put it in the Pythagorean theorem by saying 3 squared plus 3 squared equals c squared. So 18 equals c squared. So c must be the square root of 18. But since we know our 45, 45, 90 triangle follows a pattern, we end up with 3 root 2 here, which is what 18 simplifies to. Remember, that's root 9 times root 2. So we get 3 root 2. All right, and then the other side, we have another triangle here that's 2 by 2, so this side must be 2 root 2. Now for finding the area, we have to do length times width, so 2 root 2 times 3 root 2. So we can say this 2 times 3 is 6. The radicals times itself is root 4, so we have 6 times 2, or 12 units squared. All right, let's try another one. The area of square PQRS, what percent of the area of ABCD? So we need to find each of these areas and figure out, okay, that small one is what percent of the large one. Now, the large one, ABCD, is just a 5 by 5 square. So we would say the area is 25 units squared. Now, if we are looking at PQRS, these have some diagonals, and we need to make sure we know the length of my sides of the square, which in this case we have 2 by 3, meaning we need to put it in the Pythagorean theorem to say 2 squared plus 3 squared gives me what? Hypotenuse squared. So we do 4 plus 9, giving us, let's see, did I do that right? Yep, 13 equals c squared, so c must equal the square root of 13. And we actually have that on both sides. This is also 2 by 3 to get this hypotenuse. All right, so we can say that PQRS is the square root of 13 times the square root of 13, which means that I get the square root of 169, which is just 13. 13 units squared. So what percent do we have? Well, the part that we have 13 out of the whole 25, well, I could get this to 100% by multiplying by 4, so we get 52, meaning that our small square is 52% of ABCD. Okay? All right, so we have to find the areas of both and then divide them. All right, find the area of this rectangle with these vertices. So 0, 5, 3, -1, -1, -3, and -4, 3. So we have this rectangle, and it does actually make a rectangle, and we need to find the side lengths for each of these. So we're trying to find this hypotenuse and this hypotenuse, which means, let's start with the longer one. We have a 3 by 6. All right, so we're going to do 3 squared plus 6 squared equals c squared. So we have 9 plus 36 equals c squared. So we have 45. Okay, and actually c is equal to the square root of 45 when we simplify. But we need to simplify the square root of 45. Well, that's just the square root of 9 times the square root of 5. So we say that's 3 root 5. And then our other one, we have it a 2 by 4. So we do 2 squared plus 4 squared equals c squared. So 4 plus 16 equals c squared. So root 20 equals c. And we split that into root 4 times root 5. So that's 2 root 5. Now, to find the area, I need to multiply these together. So we have 2 root 5 times 3 root 5. I multiply the 2 and the 3 to get 6. The root 5 times root 5 to get root 25. Well, that's just 6 times 5, or 30 units squared. All right, I'm just going to show you a couple other examples that you can try on your own. Okay, find the side lengths so that you can find the area of this square. Okay, and think about this, how you could find the area of the shaded by a couple different methods. Think about the 2 different ways that you could find the area of this. Remember, you could take the full thing and subtract out the small triangles, or you can find the side lengths of the square, the shaded square, and multiply them together. All right, well, I hope this helps for your homework and for studying.